In this video, we're going to look at a pretty tricky question, and it's pretty tricky just to understand what's going on at the start. Once we get what's going on at the start, it's not too bad. But it says here, a bead of mass 2 kilograms is threaded onto a fixed rough vertical rod. To prevent the bead from slipping down the rod, a force P acting at 6 degrees to the upward vertical is applied to the bead. The coefficient of friction between the bead and the rod is √3/9. The bead is on the verge of slipping down the rod. Complete the force diagram below, showing all the forces acting on the bead. Okay, now if you look here, first of all, this is the diagram we have to complete. And when I first looked at this, I thought, where on earth did I put my friction and so on? Well, I thought the friction is going to be going here. Now, you are to prevent this slipping down, but you have a force going over this direction. So that means you would need to have another force going over the other direction as well in some way, shape, or form. So what exactly is going on? Now, let's just look at the two diagrams then. This is what's happening if there wasn't this horizontal force. So if there wasn't this horizontal force, to exaggerate, it would be quite possible for the bead to drop down vertically and there'd be no friction involved at all, because you can imagine here, if it just doesn't, the rod's going down the center and it's not touching the sides, there's going to be no friction. If it's not making any contact, there's no contact, there's no friction. So what happens, this force here, because this force, and they've called it P, is pulling it to the right, you can see that what would happen would be the bead would then be pushed over, and then there would be contact here. So this is where the friction is coming in. Okay, so that's why there's friction, because there is contact. So without that, force going sort of over to the right, you can see it would potentially be possible for the bead just to fall vertically downwards. So that's really what is going on. So that means the friction is going to be acting up this way. It says in the question it's on the verge of slipping, which means friction F is equal to mu r. So I'm just going to mark that going upwards. So as friction moves upwards to prevent the motion moving downwards. We also have got the mg, the weight of the bead, and also the normal reaction then is going to be going perpendicular, so at right angles to the vertical rod. So that's why it's going here. So that's everything you've got. Okay, I'm just going to mark on another wee dash line here horizontally, and then I'm good to go. So we knew as well our mu was, write that in, mu was equal to √3/9. So we're good to go. We've got everything we need. It says find P in terms of M and G. There's only two things we can do. We can resolve horizontally, and we do this. We put our force to the right equal to our force left. I'm just going to say P sine 60. We use sine because we don't have the angle, so it's P sine 60. And then is equal to, and horizontally to the left, sorry, we've got R. So that's all you have got. Now what you can do is go vertically, call that equation 1, sorry, go vertically, resolve vertically. I've got my mu R going vertically, also going vertically up, sorry, I have got P cos 60, and then that is equal to my mg. So we can change this in, put in what we know, √3/9 R plus P cos 60 then is equal to mg. And then what do we want to do here? We want to make R the subject. √3/9 R is equal to mg minus P cos 60. And then my R is going to be equal to, so if I bring that across the other side, it will divide. So dividing by √3/9 is the same as multiplying by 9/√3 times mg minus P cos 60. So that means sub that into equation 1, and it's just messy this question then, so sub into equation 1. Your equation 1 is going to be P sine 60, that should have said P sine 60 is equal to 9/√3 times mg minus P cos 60. Let's just multiply that out and bring all the P things to one side. So I'm going to have P sine 60 is equal to 9/√3 mg, and then minus 9 over root 3 p cos 60. We'll bring it across. You're going to have p sine 60 plus 9 over root 3 p cos 60 is equal to 9 over root 3 mg. And then let's work these out. So sine 60, just do those on your calculator just to check. It's calculator exam. So if you do sine 60, you get root 3 over 2. So that's just going to be p times root 3 over 2. And then next thing we're doing, I'm doing the 9 root 3 times cos 60. So just do 9 over root 3. And then times cos of 60. And if I did that in my calculator, I got 3. That should have been, isn't pen. I would have got 3 root 3 over 2. And then that just equals 9 over root 3 mg. And then let's tidy that up. That's going to be p times, and that's going to be 4 root 3 over 2, which is the same, of course, as 2 root 3, is equal to 9 over root 3 mg. And I think we will leave our answer in terms of m and g. So that's just going to be 9 over root 3 mg, and then divided by 2 root 3. So let's just do that. Let's just do 9. So what I'm doing here is 9 divided by my root 3. And then do that whole thing divided by 2 root 3. And what I got was p was equal to 3 over 2 mg. And hopefully that is what we're looking for. Let me just check. Find p in terms of m and g. That is it. So hopefully that's explained that question. That was a difficult enough question to understand just at the start exactly what was going on. But there we go.